Yeah, I'm originally from Split, come here a lot. But yeah, I really want to, I'm so excited to be part of the Shift conference this year. So today, I'll be talking how we use Cassandra at Signal. So a little bit about me. I've been in the tech industry for about 14 years, splitting my time in between the video collaboration and the digital marketing. Currently, I'm an engineering manager at Signal in Chicago. We're actually in Chicago and New York City. So I'm so excited to share our story and how we use Cassandra at scale. We grew from just a tiny startup of about 30 people to in about 2 years, we went all the way to 150 people. So it's pretty exciting to actually have technology grow with you through this journey. So a little bit about Signal. So in today's world, this is the reality of today's world. All of us just use so many different devices. And that's not just smartphones or laptops. That also includes TVs, even some gaming devices. So this makes life so much harder for any advertisements, or even just for companies that want to know what you're up to, or what kind of experience do you have using their platform or different devices. So, for example, in today's shopping experience, well, at least in the U.S., 65%, and I think it's even higher number today. 65% of consumers actually start browsing on their smartphone. And some of them still buy over the phone, which is becoming increasingly popular. But however, a lot of them just switch different devices, either go to their laptop or tablet, and there they actually complete that purchase. And that's a nightmare for any advertiser. That's just a nightmare, and because they just only actually 6% of global advertisers can confirm that they actually have a complete picture of what you're doing. And so what's really kind of the bullseye there is as if they. The hardest thing, let's say I'm buying a drone online, and I'm going through different websites, and I'm searching for a drone, and I find one and I buy it. The most annoying thing is after actually I bought a drone, to actually get ads afterwards, and I'm sure all of you had that experience. It's just so annoying. So Signal, what we do is we create this new platform that allows actually our customers basically get this relevant information about their customers in real time. And real time is the key, which I'm going to be talking about. So the platform that Signal builds, basically what we do is this massive data ingestion from all these different inputs. You can see websites, mobile apps, display ads. We also allow, and this is kind of a new thing, to do a huge batch onboarding of customers' data from our clients. And what we do is, as the data is going through our platform, we build identities, we build profiles, we make links in between all these different behaviors on behalf of our customers. So what we can do is, as we're building, this graph, we allow our customers to really get to know their clients. And so as we actually build this graph, what we can do, actually we're not in the advertising business. We just provide, we have user interfaces that our clients can use to segment their different consumers. So as they're getting in touch with their consumers on either social media or through programmatic advertising, they can really give them the relevant message. I would love if they didn't actually send me an ad after I actually bought a drone. So anyway, that's what we were trying to help. These are actually some of the ad companies that we work with on the outside. But so at the center of actually building this graph is a technology called Apache Cassandra. So we actually evaluated Apache Cassandra about 3 years ago, and there were several different technologies that we worked with that we tried, and ultimately with Cassandra, what really won us over is ability to replicate data easily across multiple regions in the Amazon ecosystem. So, and number two is like being at least this promise at the time, just like an ability to scale really quickly. So, a little bit of, so yeah, Cassandra, I think originally was developed by Facebook. In today's world, it's used, Apple uses it. Netflix is actually one of the largest users of Cassandra, and they're actually very active on Cassandra Summit and some of the other conferences that they have. So it's actually pretty used. Actually, also Twitter does use it as well, actually today. So at Signal, our Cassandra deployment is actually one of the largest ones in the US Midwest. We have about 500 Cassandra nodes, and they're actually distributed all across the world because we have clients in every region in the world, and we want to be able to, in real time, like ingest their data and also in real time, give them relevant information about their consumers. So we do about 1.5 billion Cassandra queries per day, and that keeps growing as we're onboarding new customers. So 1.5 billion queries is actually, right before that, we do about like 2 billion HTTP requests a day, and you'll hear more about it. We actually, on our front end, or on our front end, essentially, we have an HTTP API that a lot of our consumers can use. As far as the amount of data we store, it's in terabytes. I think as our clients share more and more like different attributes or behaviors about the client, the storage is growing, and our graph is becoming more linked, and we're able to provide more consumers. We definitely see this number actually going up. So this is actually how our deployment looks right now, and as I'm going to be talking about Cassandra a little bit more. But so what we do, we actually have 6 different data centers that are different AWS regions. They're actually all connected. We replicate data effectively in between regions, but this ensures that we can in real time provide relevant profiles for our consumers. So anyway, let's get back to Cassandra database. So Cassandra database is a distributed key value store, NoSQL. So when I say distributed, basically, all the data that we have is distributed on across different nodes. Like this right here is a depiction of basically how one data center looks like. You have a bunch of nodes, Cassandra nodes, and each of them has an even amount of data stored in it. So what's really nice about it is it's very decentralized. So each node in the ring is totally independent. So if a node goes down, the data center smoothly continues to operate, and it can still, it still basically makes the whole thing available. So what happens? What's nice about Cassandra is, as you're storing data, you can choose what kind of replication factor fits your needs. And the actual replication is asynchronous. So, like for example, here, let's say in the client scenario, let's say you're using a Java client that actually talks. It can actually talk to any of these nodes in the ring, and your piece of data is going to be stored on, let's say, replication factors 3. It's going to ensure that 3 different nodes contain your data. So, let's say if one of the nodes goes down, you can still successfully serve that data. With no problem. So that was replication. Now Cassandra also offers tunable consistency, meaning that like for example in my scenario, I don't necessarily have to wait until my piece of data is actually saved on all 3 nodes. I can just say, hey, just write it to the first node, first replica that you find. And then, like asynchronously in the background, sync that to other nodes. So there's this delay. And so in different use cases, like in our use case, like we can deal with that like small delay. And this actually, but then what we get because of that, we actually get this like really low latency of like saving our data, which is what actually kind of in the big picture allows us to store a massive amount of data like really fast. So that's like one key point that I want to emphasize about Cassandra is that it's really good for like write-heavy loads, and this is where it actually shined for our use case. So yeah, Cassandra is highly available, like I mentioned. So if any of the nodes goes down, it just continues to operate. And now one of the biggest promises of Cassandra is like so easy to scale. I mean, just to give you an example, so right now we grew from about, let's see, it's like in last year we grew from about like 280 nodes to 500 nodes, and we had about now three DevOps maintaining this like worldwide ring, and it's been so easy. I mean, it's as easy like you spin up an AWS instance. If you use Puppet, you just let it configure your node. And and then you just do like, service Cassandra start. That node's gonna automatically join the ring. It's gonna tell all the other nodes it's in the ring. It's gonna actually, the other nodes will stream the data to it. And so what they're gonna do is like Cassandra nodes by itself, they're gonna arrange to now, give a share of the total data to this new node, and then basically they just kind of have now less data on its own. But it's pretty automatic, very easy, and it's one of the most powerful features of Cassandra. So as far as the failure, I mean, we've seen our share of failures. Like we've survived like Amazon just like randomly swallowing nodes. It just happens. Amazon rebooting the internet, or like someone like stumbling over the cable, which is great. Which created like we actually also like lost regions, and we were able to operate continuous, which is unbelievable because our data was replicated across the world. Just common things like disk failures, encrypt SS tables, really easy to recover. Let's say node goes down, or like the node is in bad state. You just kill that node. You start up a new node. A node joins the ring, gets all the data from the rest of the ring, and you're back in business. Very, very easy. So I'm going to talk about some of the two use cases that we have for Cassandra. So what we do, as I was talking about the data ingestion, our main use case is we needed to be able to ingest a lot of data from websites, from smartphones, like really quickly. So we found this like magical combination of using Kafka and Cassandra. So Kafka is a distributed streaming platform that essentially, it's like a big queue, a distributed queue that allows us to just really quickly let our API just queue up the message to be that can be stored, and then in the background through our identity service, allow our identity service to build or add new nodes to the graph, and then actually save them in Cassandra. It works really well. Now the other use case, basically on the outbound of our platform, was we had an activation service, and actually there's also multiple of them talking to Cassandra, just like getting data from Cassandra. And then again, as we are working with some of our advertising partners, kind of the inverse of that pattern. We also use Kafka to queue up messages that actually go outbound to our vendors, and so our clients can display relevant ads to their consumers, or just like monitor, what their clients, consumers are doing. So, like one example, we work with some of the gaming, big gaming companies, and one thing they want to do is, across like multiple devices that gamers use these days, they just want to know like what kind of, what are the favorite games, that people use, like, what are the like behaviors they have inside of the games. So it's a really interesting use case because we allow them to basically just, give us all this data, analyze this data, and they just like, send this like more organized data like outbound to them. So it really actually worked pretty well. All right, so let's talk about a little bit about like the downsides. And this is kind of the interesting challenges that we ran with Cassandra. I mean, like any technology, there are downsides, and I think what's important is to be really aware of them so you can work around them. So the biggest one, so in Cassandra, in order to like insert data or query data, they built a Cassandra query language, so CQL. And one of the first lessons that we learned is even though it looks very much like SQL, it's actually very different. And and the sooner we realized that, and the sooner we adapted, the easier time we actually had, to scale. So for example, like what, I mean, even though like, it seems like you can do like, you can do like, a lot of like, SQL-based queries, there's still some limitations. Like one of the biggest ones is actually there's really no joins in Cassandra. And so what the general recommendation in Cassandra is like, as you're storing data, you want to actually identify different use cases and, actually create, create different tables for your use cases, because tables are very cheap in Cassandra. And then what you do is actually you join your data on the application level. So it's something just to kind of keep in mind. There's a lot of good articles out there and they're actually going into a lot more details how to do this. So like I mentioned, the second important fact is like we had a lot of data modeling pains, and just because a lot of us had a big SQL background, so as we were watching videos and doing some data modeling, and of course we did it wrong, we like get angry. But I think it's important to just kind of go through, some of these cycles and really understand, like, how Cassandra wants, how to actually model in Cassandra. One of our general recommendation is, there are a couple of different like advices that you can find online, but I think general for us is like, as we think about the problem that we are trying to solve, is really understand, how the data is going to be accessed, like the actual access patterns, build the actual queries that we think we need, and then like, based on that, like kind of go back and work with our application to make sure that we can actually solve our scenario correctly. So just like one recommendation from our side. Another actually interesting thing about, or pain point for Cassandra is, as we all know, like with SQL-based, like, MySQL, Postgres, if we need a secondary index, we just add it. Cassandra does support it, but it does not work well at scale. So it's mainly used for like low cardinality data, and this is just something to keep in mind, as you're building your database and building your schema. In the latest version, the community has built something called material reviews, which is a replacement for secondary indexes. We actually haven't tried it just yet. We actually went ahead, we actually built our own material review before even this was released, just because we needed a secondary index for our purpose. But yeah, something to keep in mind as you're playing with Cassandra. Another interesting thing about Cassandra is that deleting in Cassandra is really painful. Part of it is because it's an append-only database. And of course it's distributed. So as you're actually deleting data, what actually happens is Cassandra leaves these tombstones, essentially like marks, that's saying, hey, this piece of data has to be deleted. So what happens in Cassandra just then propagates that information to other nodes across the ring. And so then there's this process of compaction, which essentially goes through the SS tables and ensures that this data is gone. But it's still, there's this whole like time delay before your data is gone. So that could be an issue, with the disk if you're running pretty close. If you're working with a lot of data, deleting a lot of data, you have to like keep an eye on the disk as well. And so compactions by itself, it is something that you have to run as part of Cassandra. They do have they put an increased I/O pressure on your system, so it's just something to keep in mind. And another thing with the deleting, we also, if you want to delete like bigger amounts of data, you can run into problems with like having to do big scans. And generally, huge scans of Cassandra are not recommended. They do, especially like if you like scan like a whole table, you usually have to like make your schema so like your tables actually contain like the specific data that you want to target, either for deleting or like reading and so forth. So what's really nice about Cassandra, community is really strong, and this is something that I'm going to like keep repeating. So testing is a huge thing. Like at Signal, we do a lot of testing. All of our developers have their local environments where they have their own deployments of Cassandra locally with not exactly the same replication as in production, but enough replication that we can test. So there's these two libraries that we use extensively. So Cassandra Unit, by the way, most of our services are in Java. So Cassandra Unit is a Java, Java package that allows you to test your queries like locally before even like releasing into production. Now, the other big player, Netflix, they have, I mean, their ring is huge, and for them, losing data centers, losing nodes is a pretty big deal, because then, so what they created a whole suite of utilities that you can use to basically test the resilience of your ring and your global deployment. So with an appropriate name, they call it Chaos Monkey, which basically just like goes around your ring, and you can like target and basically just shut down data centers, shut down different nodes, and really see how your even your production data center reacts even before it actually happens. So I really like they have a lot of really good tools that I highly recommend to check out. So at Signal, we're really big at monitoring, and this is something that we started early on. From when we're such a small company. We use a combo of, we actually use a lot of open source utilities. We use a combo of like Graphite and Grafana. We're actually huge Grafana fans. We really wait until either like that the open source tool can't really handle the amount of data we're actually using to actually pay for tools like, but like right now with Grafana, we're able to like really closely monitor Cassandra. So yeah, so monitor is huge. Like for example, like some of the regular things that you want to monitor with Cassandra, just because writes are really fast, reads are the ones that can slow down, and it's tied to the compactions or just like the general level of a load on your ring. So yeah, we monitor our P99s, P79s, and mean read latency in all the different regions, so we can quickly know whether the ring or actually a specific node is not operating well. So this is also all connected with PagerDuty alerts, so we can get informed only when needed. Then we can jump in, and if the node is in bad shape, either due to like SS stable being in bad shape or just like general health. The nice thing is like you can just shut down that node, get it out of the ring, and the rest of the nodes will just like pick up like really minimum effort. And that's what we really love about Cassandra. Some of the other things, like just like some of the general Cassandra health, we love to monitor, like the disk space, compactions, because like since compactions are tied directly to the health and the health of different nodes, we definitely want to know like if they're happening, and just like some general like node information like memory used and things like that. So since like Cassandra is a Java app too, another thing, the two things that involve a lot of tuning is obviously JVM tuning, and that's by itself could be a whole separate talk. There's a lot of stuff that can be done there, and I think it's important to be involved with the community to see what are the others experimenting with, what are the results they're getting. So like right here, we're also monitoring. The second thing that it's important to monitor is actual garbage collection. And as you can see here, like on the bottom, that's like the pattern of like, let's say healthy nodes. And you can see how quickly we're able to just like see, oh, there's like 3 nodes, they're like really slow for whatever reason. But and this can also be like connected with the PagerDuty alerts, which can alert you pretty quickly that something's going on, and then you can look at it. So it's really nice. We're huge fans of Grafana, Graphite, and some of the other tools as well. So in the end, I think as Cassandra was evolving, the community was evolving as well, and community is really strong. So it's really nice. We as Signal, we participate in Cassandra Summit and some of the other conferences that are tied to Cassandra. We work really closely with, as we find bugs in Cassandra, we report them. We work with the community on fixing them as well. So Cassandra is under the Apache community, the open source one. There's also a paid version of Cassandra that's run by DataStax, and they've done a great job of basically combining Cassandra with Spark, with Elasticsearch, and some of the graph, and adding some of the graph features to it. So they also do any changes they make, they do contribute them back to the open source Cassandra too. So it's nice to be a part of both of the communities at the same time. So just to kind of end up, what I was saying. So yeah, so what we really love about Cassandra is like the easy, ease to scale. And what was really nice is like, from the beginnings of the company, even like today, the technology really scaled with us. And I think that's what we like the most, especially for any like write-heavy loads or workloads. Cassandra is a perfect scenario. As far as like reading data from Cassandra, we've also played with like Spark and some of the other elastic MapReduce technologies just to get data at scale, but Cassandra performed really well. So I highly recommend trying out Cassandra if you guys have a chance. We had some really good luck with it. So yeah, so in the end, I just want to say Signal is actually hiring. If you guys are interested in learning more about how we use Cassandra, just find me after the talk. And I hope you enjoyed my presentation.